Yesterday, you guys looked at graphs of polynomial functions and wrote the equation. Today, we're going to get the equation, and you are going to create the graph. First thing we have to do is to determine what our end behavior is of the function. To do our end behavior, if you need to go back to your 3.1 notes, pull those out. But we need two things. Our leading coefficient, that's going to be whatever is in the very front of our polynomial. And then we also need to know our degree, meaning we're going to have to add up all of the exponents to figure out the total degree of the polynomial. Remember, if there is no exponent on a variable, that means its exponent is 1. So here, if we add up all of our exponents, we have a squared. This would end up being a 1. This is cubed. So this tells us that our degree of this one is equal to 6. So it would be an even degree. Whereas if we look at this one, we have another degree of 1, 2, 1, and 3. Add all of those up together, and here we're going to have a degree of 7. So it would be odd. Once we have that, we're going to find our zeros, determine the multiplicity to figure out if they bounce or cross. Then we'll find our y-intercept. When we do our y-intercept, we're going to plug in 0 for each x value, and then solve from there. And then we connect all of our points to get our graph. So for our first step is that end behavior. Let's look at our leading coefficient. We see a negative here in the very front of the polynomial, telling us we have a negative leading coefficient. And then to figure out the degree, we have to add all of those degrees up together. We've got a squared, a 1, and a 4. So that will end up giving us a degree of 7. So if we have an odd degree, that means we're going in opposite directions. Remember, negative means we have like a negative line. So our end behavior is up and then down. Second thing we're going to do is we're going to find our zeros. That's what we did yesterday, where we said we look in each set of parentheses and say, what do we get when we solve for x? So if we have x plus 3 equals 0, we subtract 3 to the other side, and x equals negative 3. We'd also have x equals negative 1, and x equals positive 2. Now we can determine the multiplicity of each of these. Remember, our multiplicity is the exponent from the factor it came from. The stuff that we have highlighted in yellow up there. So here we have a multiplicity of 2. Then we have a multiplicity of 1 and a multiplicity of 4. Now those multiplicities help us determine our behavior. Since we have an even multiplicity of 2, we know that we are going to bounce at negative 3. A multiplicity of 1 tells us we're going to cross at 1. And a multiplicity of 4 tells us we're going to cross, just kidding. An even multiplicity of 4 tells us we're going to bounce there at that 2. And then lastly, let's find our y-intercept before we connect all these points together. So we're going to have a negative times 0 plus 3 squared times 0 plus 1 times 0 minus 2 to the 4th. Yes, you guys can do this all mentally, but I'm going to tell you, plug it in. It's going to be a lot faster if we do it in our calculator. And you can ignore the zeros when you type it in, since they don't mean anything. But we type this all in, and we're going to find that our y-intercept is negative 44. So now let's go ahead and sketch a graph here. So first, our end behavior. We said it was up on the left and down on the right. Then let's put some tick marks for our x-axis. And we're going to put our zeros here at negative 3, at negative 1, and at positive 2. And then we're going to have our y-intercept. This is definitely not to scale, but we're just going to say it's down here at negative 144, just so we know we have to go through that point at some point. Now let's connect these points, and what we really need to focus on is this multiplicity, whether we bounce or cross when we get to each of these x values. So we're going to start coming down towards our x value of negative 3. Now the question is, do I need to go through this line or come back up? Well, at negative 3, our multiplicity told us we were going to bounce. So we're going to come back up. Then we're going to come back down towards our x value of negative 1. The multiplicity here told us that now we're going to cross at negative 1. meaning we go to the other side of our x-axis. And if we look, we had our y-intercept down here, so that means we're on the right track. We'll connect through it, and now we'll come up to our x-intercept of 2. We said that we bounce at 2, so we're going to come back down, and that connects us to the end behavior that we said we needed. So we can feel pretty confident that we have found all the correct information and given the correct sketch. For our last example, we're going to do the first step together and then have you guys finish off the rest of the steps. So to find our end behavior, we need to look at our leading coefficient. This time, it's going to be a 3. We don't really care about the number, we just care that that 3 was positive. Then we need to find our degree, add up all of those exponents. We've got 2, 1, 3, and 4. That will give us 3, 6, 10. So we have an even degree. Even degrees mean we're either going up, up, or down, down. Since we had a positive coefficient, that's going to tell us it's going up, up. Pause the video, find the rest of the information, then come back to check that you have the correct information. Here are all of our zeros. You might have forgotten that x equals 0 right here. If you did, remember that anytime we have an x that's not inside of a parenthesis factor, its solution is 0 because 0 squared is the only way to get back to 0. Then we have the multiplicities, which aren't super important, but they do help us then figure out whether we're bouncing or crossing. So since 2 and 4 were even multiplicities, we bounce at 0 and at 5. 1 and 3 were odd, so we're going to cross at both -4 and 2. And then lastly, our y-intercept. When we plug in a 0 for all of our x values, well, what happens here in the front is we end up with 3 times 0, which is 0. And then we're multiplying all of this by the 0 from the front here, which means we don't care what numbers we get after this, because they're all getting multiplied by 0 in the end, leaving us with a y-intercept here of 0. If you did not get 0, it's probably because you forgot to include this 0 here in the front. Now that we have all the correct information, pause again, graph it, then come back to see how your graph looks. Here is our graph. So with our up, up, end behavior, we're going to see as we come and approach our first 0 of -4, we said that we had to cross, so we're going to go to the other side. We then come back up towards 0, where we said we were bouncing, which is why we come back down. We then come back up towards +2, where we said to cross. And then we come back towards 5, where we said we were going to bounce. And that connects us back to that up-end behavior we needed on the other side. So even though our zeros were not necessarily given in the order here that they appeared here on our graph, just make sure that as you approach the certain number, check for where that number came in your work to know whether you're crossing or bouncing.